talk acceleration. What is it? Acceleration is the rate of the change in velocity. So what's that actually mean in English? I mean, if you're driving along and you put your foot down on a car and put your foot down on the accelerator, you'll speed up. And the question is, how much do you speed up every second? How fast do you increase your speed? And that's acceleration, is how fast are you speeding up? So that means we need to know certain pieces of information. There is a change in velocity, so we need to know there's a change in velocity. Remember, when we're doing change in velocity, so that's velocity, and velocity is measured in meters per second. Remember, whenever we have a change in anything, it's going to be the final amount minus the initial amount. The other thing that's important is how long does it take to speed up or slow down? And that is going to be change in time. How long? So this is going to be time's measured in seconds. And so acceleration is equal to the change in velocity, how fast you speed up, divided by how long it takes to speed up. And that's going to be measured in meters per second, divided by seconds, so meters per second, or meters per second squared. Now, there's lots of ways of writing this down. At high school they get really fussy. Sometimes you'll see it like that, sometimes you'll see it like that, ms to the minus 2. Sometimes you'll see it like that. As far as I'm concerned, being a physicist, those are all correct. You can use any one of those. But if you're at a high school or something and they say use that, you must use that. But most physicists, we read that and it all means the same stuff to us. Okay, so the acceleration is change in velocity over the change in time. How long does it take to change time? So let's do an example. A dragster goes from 0 meters per second to 60 meters per second in 5 seconds. What is the acceleration? Well, okay, let's try it. First of all, draw a picture. There's lots of reasons for this, but people actually solve problems better if they do draw pictures. Even a simple one like that. Write down what you know. Well, we know it started at 0 meters per second. It finishes at 60 meters per second, and the time is equal to 5 seconds. We know acceleration is equal to change velocity over time. So what's the change in velocity? The change in velocity is equal to Vf, the initial final velocity, minus the initial velocity, which in this case is going to be 60 meters per second, minus 0 meters per second equals 60 meters per second. Okay, bit trivial, I know. So acceleration is going to equal 60 meters per second, because that's the change in velocity, over 5 seconds equals 12 meters per second squared. For a standard road car, that is incredibly quick. For a dragster, not so much. Okay, let's do another example. I am driving at 30 meters per second and see a policeman. So 30 meters per second is a little bit faster than the speed limit where I live. I apply the brakes and slow to 25 meters per second in 2 seconds. What is my acceleration? Okay, same thing. You draw a picture, me in car, going that way, see a policeman. So I better stop, apply the brakes. So VI equals 30 meters per second. VF equals 25 meters per second. T equals 2 seconds. Okay, and now change in velocity equals VF minus VI. VF is 25 meters per second. VI is 30 meters per second. That means my change in velocity is negative 5 meters per second. What that means, the negative signs means I slow down. If it's a positive sign, I'd speed up. If it's a negative sign. So A is equal to change in V, change in T, which is equal to negative 5 meters per second over 2 seconds equals minus 2.5 meters per second squared. Okay, that minus sign tells me I'm actually slowing down. If that was a positive sign, I'd be speeding up, but as that is a negative sign, it's slowing down. And in the trade, we call that deceleration. So if you've got acceleration, you're speeding up. If you've got deceleration, you're speeding up. Or we can just say this is a negative acceleration. Okay, so hopefully this is of some help to you. We will do some more of this when we get on to the kinematic equations.